Okay, so in this lecture, I want to start talking about propositional logic. And you will sometimes hear this called symbolic logic. They basically mean the same thing. And there's reasons to call it either thing. Um, I took an entire class on propositional logic back when I was an undergrad. They called it symbolic logic. Whatever. Tomato, tomato. Just know that if you hear somebody talking about symbolic logic, they mean the same stuff that we're dipping our toes into in this class. All right, so what is propositional logic? Well, the basic idea, remember way back at the beginning of this class, we talked very briefly about propositions, right? Propositions are just very, very basic claims. Um, you know, and the idea is you can use letters to stand for simple propositions, and then you can use some symbols to represent the logical relations between those propositions. So why do this, right? I'll talk about the symbols in a second. Why do this? Well, you do this because it's very, very, very precise. Ordinary language is vague, it's unclear. Symbolic logic is not. It is, if you write a sentence in symbolic logic and you do it right, there is no doubt in the world about what it means. So it's precise, which is a very good thing for logic, right? If you put a statement in propositional logic, it's clear what it means. You don't have to puzzle it out. And, when you think about how to represent what other people write in symbolic logic, sometimes it'll be vague and you won't be able to decide between, okay, do I put it this way or that way? But you have to engage a lot with the logical form of what people write to put it in symbolic form. So the very skill of translating into symbolic form will, I think, really help us understand the logic of a lot of arguments better. And then finally, symbolic logic just really represents the form of arguments super well, right? Logic is about the form of the argument, not the content. Symbolic logic just does away with the form entirely. We strip down whole sentences to just letters. We'll see what that means in a minute. But, symbolic logic, we see the form. Everything else in the argument gets lost. It's very, very, very good for seeing the form of the argument because it really just pitches all the content, doesn't really look at it too closely. All right, so that's why we learn it. One more reason to learn it is that I think it's useful in other classes. Sorry, I need to say this. If you take advanced math classes, especially classes on mathematical proof, symbolic logic will come up. It'll be like one of the first things you look at. You'll also talk about set theory if you take advanced math classes. Set theory is a slightly different thing, but it really works with a lot of the same concepts as symbolic logic. It's almost, I would say the two are almost dialects of the same language, right? If you do computer programming, one thing you guys will quickly notice is that the way that computers, quote unquote, think really in a lot of ways comes back to the way symbolic logic handles language. I won't bore you with this, but symbolic logic was invented early 20th centuries, and in a lot of ways, the way symbolic logic treats language, treats ideas, is what made computers possible. So it will be useful, it will be interesting, I think, if you do that. For everybody else, though, I just think it will really help you in thinking about logical relations. All right, so that's my spiel for why we're doing this. Now let's see what it actually is, right? So look, if you have a really simple proposition like Norfolk is a city in Virginia or Virginia Beach is a city in Virginia, you can just put a little equal sign, pop in a letter, and you're done, right? Norfolk is a city in Virginia equals N. Virginia Beach is a city in Virginia equals B. It's all you need for those simple claims. But how do we represent, how do we handle more complex sentences, more complex strings of propositions in English, right? When you start to think about this, you will notice that most English sentences actually have more than one proposition. When they do have propositions, well, how do you handle that? How do you represent maybe the relationships that might hold between those propositions, the ways they might relate to each other? Take, for instance, this sentence. Both Norfolk and Virginia Beach are cities in Virginia. How would you represent this? Well, look, the key here is to think, well, what does this sentence mean, right? What this sentence is saying is actually it's just saying the two simple propositions we've looked at. Norfolk is a city in Virginia. Virginia Beach is a city in Virginia. Well, then we add one of our symbols. Here it's saying, well, they both are. Well, our and symbol. Lavin uses a different one. I think this is better because it's way easier to access on your keyboard. The little ampersand. You'll see this in a lot of logic books. N and B, right? Norfolk is a city in Virginia Beach, and Virginia Beach is a city in Virginia Beach. We just pop our little and symbol in there, and we're done. Now, for the moment, we're going to add a couple more as we get more deeply into this, but for the moment, we're only going to look at 3 of these little symbols to represent, ordinary English and the relations between the things that people claim in symbolic form. Conjunction we've already looked at. And conjunction, little ampersand symbol, when you see and or but in a sentence, that is almost always a good sign that you are using conjunction, right? And think about this, right? You might say, well, why do we treat and but the same way? But really doesn't say anything different than and, right? And says, well, this is going to happen and this is also going to happen. When you say but, all you're really doing is saying and you're also expressing maybe some surprise, or you're saying, well, it's weird that these two things are both going to happen, but they are, right? Let's imagine that two people hate each other, and you say, well, Jim was at the party, but Bob was also there, right? You're saying the same thing as, well, Jim was at the party and Bob was also there. You're also just maybe expressing a little surprise that these two guys who hate each other are in the same room or have the same friends, right? But you expressing that really doesn't come back to what the sentence means. So we treat these two the same. Disjunction. Disjunction is just a very, very fancy way of saying either or. Use our little V symbol. C or B, right? We'll talk about what this means in a second. Negation is just a way of, it's exactly as it says, negating or saying that a claim is not true. So let's look at these in a bit more detail. We've already looked at conjunction. Let's look at disjunction and negation. Disjunction. Either Chesapeake or Virginia Beach is the largest city in Virginia by population. We'll use B here. We'll use it to stand for use B here to stand for Virginia Beach is the largest city in Virginia by population. C equals Chesapeake is the largest city in Virginia by population. Well, B or C, right? One of these is true. B, Virginia Beach is the most populous city. C, Chesapeake is. B or C. That's all our little wedge or V symbol means. And you can just, just use a lowercase v on your keyboard for this. That's all it is. Negation is just saying, when you see a not in a sentence, that's what negation represents, right? Winston-Salem is not a city in Virginia. So how do you represent this? You just say, well, you take this sentence, Winston-Salem is a city in Virginia, and when you say Winston-Salem is not a city in Virginia, you're just saying that this isn't true, right? So Winston-Salem is a city in Virginia. Put our little, I think it's called a tilde symbol there, and you have not Winston-Salem is a city of Virginia, which is a less grammatical way of saying Winston-Salem is not a city in Virginia. Now, you can use propositional or symbolic logic to represent either deductive or inductive logic. Deductive is a little more basic. Before you can really learn how to use this to represent inductive logic, you have to see how it's used to represent deductive. But you can change a few things, and you can use this to represent relations in inductive logic too. For the time being, we're going to talk a lot more about deductive though. All right. So, also you want to talk about truth tables and truth values. Lavin doesn't talk about these. To start with, he waits a long, long time. And I think that's kind of a mistake because these are really, really important in understanding what's going on here and understanding what our little symbols mean. So, all right, what do we mean by truth values, and what is in the world is a truth table? All right, in deductive logic, which I said is the most basic thing you can do with propositional logic, every statement, every claim, every proposition gets assigned a truth value. It's either true or false. You can represent this with a T or an F. Remember, like I said, deductive logic is all or nothing. So you can also think of this as ones and zeros, right? Again, if you think about computer programming, probably see how this is very useful for representing stuff there, right? If we can put everything 1 or 0. But anyway, this is called a truth value. Now, the connectives, the little symbols we've been looking at, which sometimes here called connectives, partially they're defined by their ordinary English meanings, right? But if you want to be precise about this, and logic is always very interested in being precise, the real definition of these symbols is their truth values, when they are true or false. And again, when you start looking here, you can almost think of these symbols, as like mathematical formula in algebra. You're using letters to represent stuff, you're putting symbols between those letters. But a big difference here is that there's only 2 possible answers, true or false. Mathematical formula, all kinds of stuff can come out of your formula, all the different numbers. Symbolic logic, deductive logic at least, only one of 2 things can pop out, true or false, right? All right. So let's start with negation. And ask yourself, if you're negating a letter, if you're saying not A, when would that be true? When would it be false? Look, not a trick question. Not A is true when A is false, right? Look at our bottom here. A false, not A is true, and not A is false when A is true. So in our top line where A is true, not A is false. And this thing you're looking at here is called a truth table. And these have a few uses, but one of the main ones is we just use them to define what the connectives mean, right? Conjunction. Well, what's the truth value of A and B? When is A and B true? When is it false? Well, A and B is true when both A is true and B is true, right? If I said Norfolk is a city in Virginia Beach, Norfolk is a city in Virginia, and Winston-Salem is a city in Virginia, that sentence would be false because even though the first part's true, I put an and in there and the second part's not. If I say Virginia Beach is a city in Virginia and Norfolk is a city in Virginia, the whole statement is true because both parts are, right? So conjunction A and B only true on this very top line when A and B are both true. When A is false, it's false. When B is false, it's false. When both A and B are false, it's false, right? Now we'll talk a little bit more about how to create truth tables, but the point here is to just represent all the possibilities, right? And see what A and B looks like in each case. Now, of the symbols we've looked at, the only one that's tricky is disjunction. Disjunction means either or. Well, what would you think a truth table for either or would look like? When would you think that an either or statement is true? Here's a common but wrong answer. When I say either A or B, you might think, well, if both A and B are true, then the statement either A or B is false, right? This top line here and this this top line here and the bottom line are both false because, well, if both claims are true, either A or B is false, and if neither is true, A or B is false. It's only true when one is false and one is true, right? That's not actually true of the way the symbol works in symbolic logic. In symbolic logic, A or B is only false when both A and B are false. If A and B are true, both true, then the statement is true. Well, now look, you might think this is weird, but I want you to notice something. We actually use either or in different ways in our language. Sometimes we use either or exclusively, right? Either or exclusively, we mean one of these is going to happen, but not both, right? Either an American League team will win the World Series or a National League team will. Can't be the case that both will, right? Either the Democrat will win the presidential election or the Republican will. They can't both win, right? Sorry, the Libertarians and the Greens are not going to win. Not in my lifetime, at least, right? The waiter comes and he says, you can have the salad or the French fries. You can't have both, right? That's the exclusive or. But a lot of times we use or, and I think it's slightly uncommon, but we use an inclusive or, right? If you have kids, if you have babies, one common inclusive or is the baby's either poopy or he's hungry, right? Well, sometimes you'll find when you change the poopy diaper, he quiets down, or you feed him, he quiets down. But a lot of times, the baby is both, right? Baby's poopy or hungry. Well, that's true when the baby is poopy. That's true when the baby is hungry. That's true when he's both. A lot of times you have to feed him and change his diaper, right? Or, think of this. You go to the doctor and he says, well, your blood pressure's a mess. You either need to go on medication or, we could try diet and that might get it down. You need to do one or the other, right? And your doctor might say, look, do you want to try diet or me put you on medication? Look, you might do both, right? The doctor's not saying, well, if I put you on medicine, you can't go on a diet because horrible things will happen, or if you go on a diet, I can't put you on medicine because horrible things will happen. He's saying you have to do one or the other. If you're really worried about your blood pressure, you could do both, right? This is the inclusive or, and disjunction as we use it in symbolic logic uses the inclusive or, which we use in English, maybe slightly less common than the inclusive or, but it's not utterly bizarre, right? And you can represent the exclusive or using the materials we already have on the table. In fact, that's a question I want you guys to think about for next time. What would, and this is a little challenging, especially with what we have on the table already, you might need a little bit more, but what would an exclusive or look like? Just a hint, you're going to have to use all the symbols we currently have to get it, but you can do it with what we have already. All right, so hopefully you guys understand what these basic symbols are. We're going to do a lot more practice with putting ordinary English language sentences into symbolic form and back, but right now I just want to introduce them.